Algebra 2. This is Mrs. Metler here with another video for everyone. Today we're going to be talking about the zeros and remainder theorem. There are three mathematical ways that we can find zeros when given an equation. We could factor them. We have done a video about factoring with grouping and big X and GCF and difference of squares. So that's one way to find zeros. We can also graph it and actually look at where the zeros are on the graph. And then last but not least, we can use synthetic division. Now, if you remember from class, we also use long division. But since we are in a strange situation right now, I am not going to review any long division for you guys during this time period. Okay, so we're going to start with factoring. And the way we find zeros when we are given factors is that we take each factor, which is each set of parentheses, and we actually set it equal to 0. Because what we are saying is that if one of these sets of parentheses actually becomes 0, anything multiplied by 0 is, of course, 0. So this whole thing is going to become zeros. So we have three different places that this graph is going to create 0. So if we actually solve these equations, we're going to get 2, -3, and 1. And of course, these are all three separate from each other, but all important at the same time. So we have three different zeros here. The process is going to work no matter if you have 10 sets of parentheses or if you have 3 or 4, which is usually what we will see in Algebra 2. So I'm going to repeat this process over. I'm going to set each set of parentheses equal to 0 because, again, I am saying that there are three different places this graph makes 0. When I go ahead and solve, I'm going to get -4, -5, and +3. And I know a lot of you guys can actually do this process in your head, and that is fine. So if you know that basically all you're doing is flipping the sign, then you are good to go. Now, when we get to something, for instance, that we can't factor, this could be a grouping problem, but as you see, 1 and 2 and 5 and 6 don't have anything in common, so it's not really going to work out to split it. So when we do this, we actually want to graph it on a graphing calculator. This is Desmos, which is an app that I've shown you guys before, and it is totally free. You can also use GeoGebra, and I'm going to post a link later to a graphing calculator from the TI website. So you see, I have this graphed with a red line, and then to find my zeros, what's really nice about Desmos is I can just click on them, and it actually gives me them as ordered pairs. So, returning back to my page, I can see that I have a 0 at -2, 1, and 3. So if I actually wanted to then write this in factored form, I could say x plus 2, x minus 1, and x minus 3. That would then tell me each individual 0. So remember, again, to go backwards, we flip the sign. So we have a 0 at -2, 1, and 3. This is something that is just too large for us to factoring. We don't know how to factor something with 5 terms. So I'm going to go ahead and graph it again on Desmos. I'm going to click off of this and turn this one on. If I zoom out a little bit, I can see that I have a polynomial here, and we see that it hits the 0, the x-axis, 4 different times. So I'm going to zoom in a little bit and make sure I can see those clearly. I'm going to click on each one, and you can probably see pretty clearly that what they go through on the x-axis is actually the 0. So I have a 0 at -5, -2, 2, and +4. So again, I'm going to go ahead and I'm going to put that back into factored form. So I'm going to say we have x plus 5, x plus 2, x minus 2, and x minus 4, and there are my 4 zeros. Again, 4 of them, that's because of the degree of 4. We have 3 of them, that's because of the degree of 3. Remember, the biggest exponent usually matches how many zeros you actually have. So those 2 ways we focused on a ton first semester, and then we transitioned into synthetic and long division this semester. So synthetic division was the shortcut way, and we can use synthetic division on a polynomial to find out what the remainder is. If the remainder is 0, then it's a 0. So we are really looking for where the remainder equals 0. If it's anything else, it's not a factor. So to set up synthetic division, what we are going to do is we are going to take our coefficients. Remember, the coefficients are the numbers in front. So I'm taking this and dividing it by x minus 1. So what I really want to know is I want to know what's the remainder when we take this polynomial and divide it by x minus 1. So first thing I'm going to do is line up my coefficients. So I have a 1 in front of my x cubed since there's nothing, a 5, a 2, and a negative 8. So I'm going to go 1, 5, 2, and negative 8. And then I draw this little bracket here. And then on the outside, what we're actually dividing by is we're dividing by x minus 1. If we actually want to figure out if this is a 0, we need to set it equal to 0 and flip the sign. So we really want to know at 1, what's the remainder? Is it 0 or is it not? So I'm going to carry a 1 over here. And then I follow these steps. So I'm going to bring down my 1 first. And then I'm going to multiply 1 times 1. I'm going to bring it below the 5. I'm now going to add those 2. So 5 plus 1, 6, and then I'm going to multiply. So 1 times 6 is 6. Add 2 plus 6 is 8. And I'm going to multiply. 1 times 8 is 8. Add those together, and 0. And since there's nothing else to do here, this is actually our remainder. So our remainder is 0. So x equals 1 is a 0. Okay? Okay, let's try this again. So I'm going to make sure I line up my coefficients. So I have a 1, 6, a negative 4, a negative 54, and a negative 45. Make sure if you have negatives, you are bringing them down to your synthetic division problem. So negative 4, negative 54, and negative 45. Okay, and I'm going to make my little bracket here. My outside, I'm trying to figure out if this is a 0, so I actually need to flip the sign to see if that's true or not. So we want to see at 3, is the graph going to equal 0, or is it going to equal something else? So I'm going to carry my 3, and here we go. So I'm going to carry down my 1. I'm going to multiply. So 3 times 1 is 3. All right. Going to add 6 plus 3 to get 9. Going to multiply 27. Going to add these two together, so that would be 23. I'm going to multiply. That's going to be, let's see, 69 here. Going to add 15. I'm going to multiply 3 times 15 to get 45. Add remainder of 0. So yes, at 3, that's a 0. So x equals 3 is a 0. Okay, now this question is asking me, is x plus 2 a factor of x to the 4th minus 3x cubed minus 28x squared plus 36x plus 144? So is it a factor? Well, we need to figure out what is the remainder. Is it 0 or is it something else? So again, I start with a 1, -3, -28, 36, and 144. Ooh, some big numbers there. And I want to find out if x plus 2 is 0, which really means I am going to divide by -2. Okay, so this is a negative. We have to be very careful with our signs here. So I'm going to go ahead and bring down and multiply. Alright, and then I'm going to add, so -3 plus -2 is -5. I'm going to multiply, careful, negative times a negative makes a positive. I'm going to add, multiply, so a negative times a negative again makes a positive. Be careful, that's not 0. 72. Multiply. And I do end up with a remainder of 0, which means yes, this is a factor. So again, we're not going to cover long division again, just because we do not have time and it's going to be difficult to do over the internet. So there is a optional homework assignment over this if you would like to take it and then use that to boost your grade. I will see you guys in the next video.